Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family will be in the best of health. Lecture for grade 8, subject chemistry, chapter number 1, lecture number 16. And here is Mrs. Saira Jamal. Dear students, we have completed the syllabus of midterm, but in this lecture I am going to discuss some of the important topics of chapter number 1. One of the important topic is atomic number and mass number. Atomic number. What is atomic number? The number of protons present in the nucleus of an atom is called atomic number. The number of protons present in the nucleus is called atomic number, and it is represented by capital Z. Atomic number of hydrogen is 1 because it has only one proton in its nucleus. Another example is of the element of the atom which has 4 protons. The red balls represent protons and the blue ball represented the neutrons. How many red balls are here? 1, 2, 3, 4. It means that the atomic number of this element is 4 because it has 4 protons in its nucleus. This is the structure of atom which have nucleus and electrons are revolving around the nucleus. Mass number. What is mass number? The total number of protons and neutrons present in the nucleus of an atom is known as its mass number, and it is represented by capital A. Mass number of hydrogen is 1, as according to the definition, mass number is the sum of protons and neutrons. Hydrogen has 1 proton and 0 neutron, so mass number of hydrogen is 1. Mass number, or it is also called atomic mass. Atomic mass or mass number of carbon is 12 because it has 6 protons and 6 neutrons in its nucleus. Mass number of helium is 4. It has 2 protons and 2 neutrons. Mass number of carbon is 12 because carbon has 6 protons and 6 neutrons in its nucleus. So atomic mass or mass number of carbon is 12. To find out the number of neutrons in the nucleus, we will use the formula. Formula is capital N equal to capital M minus N. Capital N is number of neutrons and capital M is atomic mass or mass number, and small n is the atomic number. So by subtracting the atomic number from the mass number, we can get or we can find out the number of neutrons present in the nucleus of an atom. We have an example of boron. Atomic number of boron is 5 and its mass number is 10.811, and we have to find out the number of neutrons in the nucleus of boron. We will use the formula. Number of neutrons is equal to mass number minus atomic number. Mass number is 10.811 and atomic number is 5. The answer is 5.811. So by using this formula, we can find out the number of neutrons for any atom. This is a very important table in chemistry which is called periodic table. It is composed of 118 elements, and the atomic number and mass number of all the elements are mentioned in this table. This table, inshallah, you will learn in chapter number 4 in detail. Molecular mass and formula mass. What is molecular mass or formula mass? First, we will discuss about the molecular mass. We have a question number 1. Determine the molecular mass of the following. But first of all, you must know what is molecular mass. It is defined as the sum of all the atomic masses of all atoms present in the molecule. All the atoms of an element. For example, we have C6. So element is carbon, and how many atoms of that elements are present? 6. Same H12. element is element is hydrogen, and 12 atoms of hydrogen are present there. So we have to add up the atomic masses of all these elements which are present in a molecule. The formula, the molecular mass is used for covalent compound. This is molecular mass. The molecular mass is used for covalent compound. What are covalent compounds? Covalent compounds are the compounds which are made up of non-metals. For example, C6H12O6 is the formula of glucose. Carbon, hydrogen, and oxygen, all these three elements are non-metal. That's why this compound is covalent in nature. Atomic mass of carbon is 6. Atomic number of carbon is 6. Mass number 12. Mass number of hydrogen is 1. Mass number of oxygen is 16. So by using the formula, molecular mass of glucose is number of atoms of glucose into number of atoms of carbon into atomic mass of carbon plus number of atoms of hydrogen and atomic mass of hydrogen, atomic mass of number of atoms of oxygen and atomic mass of oxygen. By putting the values, 6 atoms of carbon are there and atomic mass of carbon is 12. 12 atoms of hydrogen are there and atomic mass of hydrogen is 1. 6 atoms of oxygen are there and atomic mass of oxygen is 16. By multiplying 72, 12 ones are 12, this is 1 not 12, 12 ones are 12 and 16, 6, 96. By adding all these values you will get the molecular mass of glucose, which is 180 AMU. AMU, I told you before, is a unit called atomic mass unit. Second example is C10H8. C10H8 is the formula of naphthalene. So atomic mass of carbon 12 and hydrogen 1. Molecular mass of naphthalene is number of atoms are 10. Atomic mass of carbon is in the bracket. Number of atoms of hydrogen are 8 and atomic mass we will write in parenthesis or bracket. So 10 into 12 plus 8 into 1, it will give us the answer 120 plus 8. 128 atomic mass unit is the molecular mass of naphthalene. Formula mass. Formula mass we use for ionic compound. It is the sum of atomic masses of all atoms present in the formula unit of a substance. Ionic compound, actually they never form molecule. They exist in three-dimensional crystalline structure or crystal structure. So that's why we will use a term called formula unit for ionic compound. The term formula mass is used for ionic compound. What are ionic compound? Ionic compounds are made of metals and non-metals. For example, we have an example of calcium carbonate. Calcium is metal and carbon and oxygen are non-metal. That's why this compound is called ionic compound. Atomic mass of calcium is 40, carbon is 12, oxygen is 16, and the number of atoms of calcium are 1, carbon is 1, calcium is 1, carbon is 1, but oxygen, number of atoms of oxygen are 3. So atomic mass of calcium plus atomic mass of carbon, there is no need to mention that one atom, and 3 atoms of oxygen are there, so 3 into atomic mass of oxygen. By putting the values 40 plus 12 into plus 12 plus 3 into 16, 40 plus 12, 16 into 3 is 48. By adding all these values, 100 AMU 100 atomic mass unit is the formula mass of calcium carbonate. Another example of ionic compound is magnesium hydroxide. Atomic mass of magnesium is 24, oxygen is 16, hydrogen is 1, number of atoms of magnesium is 1, oxygen and hydrogen are 2, because outside the bracket 2 means there are 2 oxygen and there are 2 hydrogen. So atomic mass of magnesium plus 2 into atomic mass of oxygen plus 2 into atomic mass of hydrogen. By putting the values 24 plus 2 into 16 plus 2 into 1 for hydrogen. By multiplying these terms, 24, 16 into 2 is 32 and 2 into 1 is 2. By adding all these values, we will get 58 AMU or 58 atomic mass unit is the formula mass of magnesium hydroxide. The method to find out the formula mass or molecular mass is totally same, but the only difference is that formula mass we use the name for or the term for ionic compound, and molecular mass, we use the term for covalent compounds. Next important topic is Avogadro's number and mole. What is mole? There are different definitions. The first definition is a mole is an amount of a substance that contain Avogadro's numbers of particles of that substance. Avogadro's number of particles are 6.022 into 10 raised to power 23. These are the Avogadro's numbers of particles of that substance. Second definition is mole can also be defined as atomic mass, molecular mass, and formula mass expressed in grams is called mole. We in the previous slide we found the molecular mass and formula mass of ionic and covalent compound. If we have an atom and the mass of that atom expressed in AMU is called atomic mass. But if we present it in gram, like suppose carbon atomic mass is 12 AMU. Instead of AMU, if we will say that atomic mass of carbon is 12 gram. So this will be the this will be called mole. So atomic mass expressed in gram, molecular mass expressed in gram, the formula mass expressed in gram is called mole. Another definition of mole is the amount of matter that contains as many atoms, ions, or molecules as the number of atoms present in 12 grams of carbon 12. 12 grams of carbon is equal to 1 mole because it contains Avogadro's numbers of particles. It is abbreviated as MOL. Mole, we can represent it as MOL, mole, and it forms a link between mass of substance and particles. As I told, 12 gram means it contains Avogadro's numbers of particles. So it means mass and number of particles, they have a relationship. It is a unit used to measure amount of substance. As we have different units to measure the solids, liquids, and gases. Like for sugar, we weight it, we use kilograms and grams. For liquid thing, we use liter, milliliter. So same for the smallest substances, atoms, molecules, or ions, we use a unit called mole. Avogadro's number. In chemistry, we deal with substances which are made up of atoms, molecules, or formula units. The counting of these particles is not possible for the chemist because one dot of a pen contains millions of atoms in it. So how can we count them if one dot of a pen contains millions of atoms in it? So the concept of Avogadro's numbers help them in counting particles contained in the given mass of a substance, and Avogadro number we represent by capital N with a capital A as a subscript. Hence Avogadro number 6.022 into 10 raised to power 23 number of atoms, molecules, or formula units are called Avogadro's number, and this is equivalent to or equal to 1 mole. 1 mole of all the substances, they contain Avogadro's numbers of particles. So 602 hexillion particles are present in 1 mole. In 1 mole, this Avogadro number, if we write it in word, we can say 602 hexillion particles in 1 mole in 1 mole of a substance are present, which is very hard to measure. Then another important topic is chemical calculation, numerical problems. We have some important formulas. By using these formulas, we can solve all those numerical problems very easily. First formula is if number of moles are given and they ask about the number of atoms, then we will use this formula. Number of atoms is equal to number of moles into Avogadro's number. If number of atoms are given and they ask about the number of moles, then we will use number of moles equal to number of atoms over Avogadro's number. Third important formula is if number of moles are given and ask about the number of molecules or number of atoms, then we will use the formula. The first formula and the third formula, they are totally same. Just instead of atom, we will use the term molecules. So number of molecules equal to number of moles into Avogadro's number. If mass is given in a numerical problem and asked about the number of moles, then we will use this formula. Number of moles is equal to mass in grams over molar mass. Second formula and this fourth formula are same, but you have to read the numerical problem or the data carefully, what has given to you. If number of atoms are given, then you have to use this formula. If mass is given, then you have to use this formula of number of moles. Mass of compound is equal to number of moles into molar mass. If number of moles are given and as asked about mass, so we have to use this formula. There is one more formula of mass, but we will use this formula of mass in the case if number of atoms or molecules are given. If number of moles are given and asked about the mass, then we will use formula number 5. If number of molecules and atoms are given and asked about the mass, then we will use this formula number 6, which is mass of atom or molecule equal to number of atoms or molecules into molar mass divided by Avogadro's number. So these are the 6 important formulas which we can use to find out the or to solve out the numerical problem. Let us do some examples to understand these formulas. Example 1.8 of your book is calculating number of atoms in given moles. Moles are given and we have to find out the number of atoms. First example is of zinc. Zinc is a silvery metal. Silvery metal, it is silver in color and it is metal that is used to galvanize steel to prevent corrosion. To prevent steel from rusting, from corrosion, it has plated with zinc or zinc coating, prevent steel or iron from corrosion. How many atoms are there in 2.5 moles of zinc? Moles are given and they ask about the number of atoms. So we will use the formula. Number of moles are given, which are 2.5 moles. Number of atoms we have to find out. Avogadro's number, I told you, you have to learn the value 6.022 into 10 raised to power 23. The formula which we have to use is number of atoms is equal to number of moles into Avogadro's number. The number of moles are 2.5. Avogadro number is 6.022 into 10 raised to power 23. By multiplying these values, we will get the answer 1.5055 into 10 raised to power 24 atoms. So as in this case, number of moles are given and they ask about the number of atoms. So we will use this formula. Number of atoms is equal to number of moles into Avogadro's number. Then B part or second part of this question. A thin foil of aluminium is used as a wrapper in food industries. All the candy wrappers, all the, you have seen the milk can, the Pepsi can, aluminium foil even we are using at home. They are made up of aluminium, which is a lightest metal. Aluminium is the lightest metal. How many atoms are present in a foil that contain 0.2 moles of aluminium? Moles are given and we have to find out the number of atoms, same like the previous question. Number of moles given are 0.2 moles and we have to find out the number of atoms. Avogadro's number, again you have to learn, 6.022 into 10 raised to power 23. Now by using this formula, number of atoms is equal to number of moles into Avogadro's number. By putting the values, you will get the answer, which is 1.2044 into 10 raised to power 23 atoms. So by multiplying these values, like the number of moles and Avogadro's number, we can get the number of atoms. So the number of atoms present in 0.2 moles of aluminium are 1.2044 into 10 raised to power 23 atoms. The same method we can use for the number of molecules. If in a numerical problem they give us the number of moles, and the question will how many molecules are present in a foil that contains zero point 0.2 moles of aluminium. Then we will use the same formula, but instead of atoms, we will add the term molecules. In that case, we will write number of molecules is equal to number of moles into Avogadro's number. In that case, we will use number of molecules. Only the term atoms and molecules will be changed. The formula will be totally same. So number of moles are there. Instead of in the data, instead of writing number of atoms, we have to write number of molecules. And same in this case, number of molecule is equal to number of moles into Avogadro's number. Example 1.1, calculating number of moles in the given number of molecules. As I told you, number of molecules if are given and they ask about the number of moles. This is totally the reverse of the previous numerical. In that case, number of moles were given and they ask about the number of atoms or molecules. But in this case, the number of molecules are given or number of atoms are given, and they ask about the number of moles. It means that for the first part of this example is formaldehyde is used to preserve dead animals. It is used as a preservative to preserve dead animals, to preserve plant specimen. So its molecular formula is CH2O. This is the molecular formula of formaldehyde. Calculate the number of moles that would contain 3.011 into 10 raised to power 22 molecules of this compound. So the number of molecules are given and we have to find out the number of moles. Number of moles we have to find out. Number of molecules given are 3.011 into 10 raised to power 22. Again, Avogadro's number you have to learn, and then by using the formula, number of molecules is equal to number of moles into Avogadro's number. This formula we used in the previous case, but in this case we will rearrange this formula. That is by taking out the number of moles equal to number of molecules divided by Avogadro's number. Now in this case we will use this formula. So number of molecules is equal to number of moles into Avogadro's number we will use when the number of moles are given. But in this case number of molecules are given and we have to find out the number of moles. So that's why we will use this formula. Number of moles is equal to number of molecules over Avogadro's number. By putting the values 3.011 into 10 raised to power 22 are the number of molecules. Avogadro's number is 6.022 into 10 raised to power 23. These are this number is called Avogadro's number. By solving this number or by dividing these two values, that is the number of molecules over Avogadro's number, we will get the answer, and the answer is 0.05 moles. 0.05 moles are the answer. So dear students, hope you understand these problems. Inshallah, we will discuss the other problems in the next lecture. If you have any problem, you can ask me through WhatsApp group. Thank you. Allah Hafiz.